Alright, this problem deals with confidence intervals, and we will use StatCrunch in order to calculate the confidence interval. Data from a random sample of airfare prices in dollars for a one-way ticket between two cities are shown to the right. And in this case, I've dropped it down so it's underneath. Use a technology tool to construct a 95% confidence interval for the population mean. Interpret your answer. And then the answer will be typed in where it says the 95% confidence interval is. We will round to one decimal place as needed. The thing with this particular problem is I cannot simply copy and paste the data numbers into StatCrunch because they are given to me in a stem and leaf plot. So what we're going to need to do is go ahead and type these in manually. And if you recall from earlier chapters, something like this is going to be, that's going to be my stem, 21, and then this is my leaf, 6, so that means that number represents 216, and we're going to type all those into StatCrunch. So we go ahead and open up StatCrunch, and then we begin typing in the numbers. We want to put this into the first column, and so we're going to type in 216, then 217, and then so on. Okay, now that we've entered all the data, and you need to confirm that you have entered all the data carefully and completely. There are 31 data values, and I do have 31 data values, and I've matched them up. Now what you're going to do is left-click Stat. Since we have more than 30 items, we can go to Z-Statistics. We'll go to one sample. In this case, we'll left-click With Data. We will left-click var1 here to bring it over to this field. And then we're going to left-click the radio button for confidence interval for the mean, mu. And then we're going to type in our confidence level. Now, StatCrunch will default to 0.95, which happens to be what we need for this particular problem. So then we left-click Compute, and we get this pop-up window right here. And that's going to give us the information that we need. We know that n is 31, which is right here. We find that the sample mean is 238.06452. This is our standard error right here, 2.41. And then we're looking at the lower limit for our confidence interval, and we're going to have that as 233.3 when we round. And then our upper